Hello everyone, my name is Mohammad Afifuddin. In this video, we are going to learn design of doubly reinforced beam with another method. Okay, in exam you can use the previous method or this method, whichever you like. Okay. So the given data is same. They will give dimensions of the beam, span of the beam, and external loading, or they will directly give bending moment and grade of concrete and grade of steel. So here is the procedure. In this type, we have to determine axiomax first. Axiomax is the limiting depth of neutral axis, and axiomax is based on the grade of steel, and we know the formula for axiomax. For Fe250 it is 0.53 into D, for Fe415 it is 0.48 into D, and for Fe500 it is 0.46 into D. Okay, so after determining the axiomax value, we will determine MU limit by considering the grade of steel and grade of concrete. Okay, here are some formulas based on the grade of steel, that is Fe250 grade of steel, MU limit is 0.149 Fsec into BD square. For Fe415, MU limit is equal to 0.138 Fsec into BD square, and for 500, that is Fe500, MU limit is 0.133 Fsec into BD square. So based on the grade of steel, we are going to use MU limit formula. After that, we will determine AST1, that is area of steel in tension 1, from PT limit, that is percentage of steel limit, and here is the short table I have given based on the grade of concrete and grade of steel. You can directly take the value of PT limit from here. Okay, and we know the formula for PT, that is percentage of steel is equal to AST upon B into D, and from that we will find out the value of AST1. Okay, now we will determine the extra moment which is to be resisted by compression steel and additional tensile steel, that is AST2. Okay, so the extra moment is equal to MU2, which is equal to total moment minus MU limit, that is MU minus MU limit, and then we will find out the value of FCC and FSC. FSC value can be calculated from D dash by D ratio, and if D dash is less than 0.43 axiomax, then FSC we will take 0.45 FCK. Then we will find out the area of compression steel. Okay, and we know the formula for compression steel, that is ASC is equal to MU2 upon FSC minus FCC into D minus D dash, and we will assume the suitable diameter of bar, and we will calculate the number of bar. Then we will determine the additional tensile steel, that is AST2. Okay, and now we will equate ASC into FSC minus FCC, which is equal to AST2 into 0.87 Fy, and from that equation we are going to find out AST2. Okay, we got the value of AST1, we got the value of AST2 here. Therefore, the total area of steel in tension is equal to AST1 plus AST2. Okay, now after that we will consider some suitable diameter and we will calculate the number of bars. And in exam, if it is asked to check the section also, then we will check for deflection, check for shear, and check for development length. Okay, so now we will take one problem and we will solve that problem by this method. So here is the problem statement. Design a doubly reinforced beam for an effective span of 5.85 meter to carry a load of 50 kN per meter including self weight. The cross section of the beam for architectural reason is kept as 300 mm wide and 660 mm deep overall. Use M20 concrete and Fe415 steel. Assume cover 60 mm. So here is the given data. Width is given as 300 mm. Overall depth, that is capital D, is 660 mm. Cover is 60 mm. Therefore, effective depth will be total depth minus cover, that is 660 minus 60, which is equal to 600 mm. Effective span is given as 5.85 meter, and here working load inclusive of self weight is given as 50 kilonewton per meter. So therefore we have to convert it into the ultimate load or factored load. Okay, so here we will multiply the working load by 1.5. So here 1.5 into 50, which is equal to 75 kilonewton per meter. Now we will calculate the bending moment, which is equal to WL square by 8. W is 75, L is 5.85. So 75 into 5.85 square upon 8, which is equal to 320.83 kilonewton meter. FCK is given as 20 Newton per mm square and Fy is 415 Newton per mm square. So our first step is to find out the Xu-max. As Fe415 grade of steel is given, so Xu-max is equal to 0.48 into D. So 0.48 into 600 is equal to 288 mm. Now limiting moment of resistance mu is limit is equal to 0.138 FCK into BD square, because it is Fe415 grade of steel is given here. Therefore mu limit is equal to 298.08 into 10 raised to 6 Newton mm. Now we will find out area of steel in tension 1, that is AST1, and before that we have to find out the PT limit percentage. So from this table, for M20 grade of concrete and Fe415 grade of steel, PT limit is 0.96%. So we know the formula of PT limit, which is equal to 100 AST upon B into D. So PT limit is 0.96, 100 into AST upon B is 300, small d is 600, and after calculating we will get area of steel 1 is equal to 1728 mm square. Now we will find out the extra moment to be resisted by the compression steel and additional tensile steel. So mu2 is equal to mu minus mu limit, and mu2 is equal to 22.75 kilonewton meter. Now to find out FSC and FCC, firstly we will take the ratio of D dash by D. D dash, that is the cover, is given as 60 mm. D is given as 600, so 60 divided by 600 is equal to 0.1, and for the ratio of D dash by D, which is equal to 0.1, FSC value is 353 Newton per mm square. As here D dash is less than 0.43 Xu-max, therefore we will take FCC is equal to 0.45 into FCK. FCK is 20, so FCC becomes 0.45 into 20, which is equal to 9 Newton per mm square. So now we will find out area of steel in compression, ASC, which is equal to mu2 upon FSC minus FCC into D minus D dash. So after putting all the value here, we will get the answer ASC is equal to 122.46 mm square. Okay, so for compression steel, we will assume 12 mm diameter bars, and now we will calculate the number of bars. We know the formula for number of bars, total area of steel upon area of one bar. So area of steel in compression is 122.46, area of one bar is pi by 4 into 12 square. Therefore number of bars required is 1.1. So we will provide 2 bars. Okay, so provide 2 bars of 12 mm diameter as compression steel. Now our last step is to find out the area of steel in tension. So firstly, ASC into FSC minus FCC is equal to AST2 into 0.87 Fy. After putting all the value and putting AST2 unknown, so we can get the value of AST2 is equal to 116.68 mm square. So we know the value of AST1, we know the value of AST2. Therefore, we will find out the total area of tension steel, that is AST, which is equal to AST1 plus AST2. AST1 is 1728, AST2 is 116.68. So total area of tension steel AST is equal to 1844.7 mm square. Now we will assume 25 mm diameter bars. Therefore number of bar is equal to 1844.7 divided by pi by 4 into 25 square, which is equal to 3.75 bars. So we will provide 4 bars of 25 mm diameter as tension steel. As in this problem, it is not mentioned to check the section, therefore we are not going to check the section here, and here we have completed this problem. Thank you.